Now, we've spent quite a lot of effort talking about mechanical work specifically. But of course, as you remember from MEP2, there's other types of work that we deal with in our thermodynamics problems as well. Other types of work include shaft work, and so that's basically any work that's due to a force that's acting on a shaft to turn it against a mechanical resistance. So that's the technical definition of it. So work due to a force acting on a shaft to turn it against a against a mechanical resistance. And so whenever you hear shaft work, all you have to do is just think of mixing. So think of mixing. Alright, and so to illustrate this, just think of you have some sort of tank with a liquid in it, and you have an impeller or blades that are spinning, and so the liquid is being mixed. The force exerted from the liquid onto the blades, or vice versa, that's what we're going to be considering shaft work. Alright? And so in this case, if the blades are spinning and causing the liquid to mix, the work here is going to be greater than 0 because energy is transferred from the impeller to the liquid. Alright, so in that case, the shaft work is positive. And so I'll also abbreviate our shaft work as W subscript S as well. Okay? And so shaft work not only applies to impellers, but pumps also require shaft work. Well, also exert shaft work. Yeah. Alright, so shaft work is one type of work that we deal with. Another common one that we deal with not only in this course, but also in your transport phenomena course is flow work. Right? And so this is work that's performed when a fluid is pushed into the system from the surroundings, and also the work that a system does to push a fluid to the exit of the system. Alright, and so I'll write all that down. For when a fluid is pushed into the system by the surroundings, and the work a system does to push fluid to the exit. Okay? And so here, when you think of flow work, just like in transport phenomena, what you should think of is pressure gradients and friction. Okay? And so when you think of flow work, the picture that you should have in your head is just kind of think of like a cylinder, cylindrical tube specifically, where you have a fluid going in on one end of the tube at some pressure 1, and a fluid coming out of the other end of the tube at pressure 2. And pressure 1 is going to be greater than pressure 2. Okay? And so the work it takes to push the fluid through this cylinder, that's what flow work is. Okay? Alright, and so when you think of flow work, which we'll abbreviate as WFL, and we typically think of flow work in terms of rates. It's going to be the difference between the input flow work, where P of J is the pressure at the inlet or at the input, and V of J is the volumetric flow rate of that species. So we take that product and subtract it off the output terms. And I want to emphasize that you should pay attention to the order here, right? It's going to be input minus output, all right? So I'll circle these for emphasis. Pay attention to order. And when we think of the volumetric flow rate of the fluid, that's going to be equal to the mass flow rate of that fluid times its specific volume. So if we plug in this identity into our flow work equation, what we have is the flow work now in terms of mass flow rates. Okay. And so we're going to use this identity fairly soon enough when we start talking about the energy balance for open systems. Before I end this section on work, we only covered, to be quite honest, very few examples of work, but there's many types of work that exist in the universe. And so other types of work that you may deal with in your life include electric polarization, magnetic polarization. So if you're dealing with a magnetic material, surface deformation. So let's say a bubble forms within your system. What is the work it takes to actually form that bubble? On a more macroscopic level, there's also stress-strain behavior. How well can a material handle the fact that you're applying a strain on it? And of course, we're chemical engineers, so we're also going to be dealing with chemical work as well. And that will come up towards the end of the semester.